Hello everyone, welcome back to AA Academy. Today's topic is Ohm's law, that is a George Simon Ohm. It is just a simple relationship between voltage and current, or its potential difference and current, so that you can state this Ohm's law by considering a resistor which is connected across a DC supply. Whenever the supply which is given to the resistor, current starts to flow through it. So now we can call this resistor as a conducting material. So that so if the current that flows through the two ends of a conductor, that is a resistor from A to B, that will be directly proportional to the voltage across the 2 points, provided whenever its temperature and other physical quantities remains unchanged. So once again, you can understand, it states that the current flowing through the two ends of a conductor is directly proportional to the voltage across the 2 points, provided its temperature and other physical parameters remains unchanged. So that mathematically you can write it as current I is directly proportional to voltage across, or else voltage across the 2 points of the conductor. So to remove this proportionality constant, you are introducing a constant called a resistance. A resistance is a property by virtue of which always opposes the flow of current. So that you're writing V equals to I into R, like this. You can see here V equals to I into R. You just consider this triangle, that is voltage current resistor triangle. You can call this as Ohm's law triangle. So if you want to know the voltage, you can get multiplied by I into R. Similarly, if you want to get to know the current, you can get V divided by R. Similarly, R you can get it by V by I. So it is very easy to remember the relationship between voltage and current with respect to the resistor. That is resistance. Okay. So that V equals to IR, I equals to V by R equals to V by I. So to understand this, just see one funny clips you can observe. So here you can check a funny clips Ohm's law how it states. See voltage. You can observe here V Ohm is nothing but resistor, A is nothing but current. So if you wanted to get V, you need to multiply with this current into resistor, that is I into R. Similarly, if you want to get to know the value of resistor R, you should have to divide this voltage and current V by I. Similarly, if you want to get this current, you should have to get V divided by R. Very simple and funny animation to understand the Ohm's law. So what will be the limitations? So one thing you observed in a statement that at constant temperature, current flowing through the conductor is directly proportional to the voltage across the conductor. That's nothing but at constant temperature. Where there is a constant temperature parameters, there you can apply Ohm's law. So the limitation is nothing but it is not applicable for non-linear devices. So what are the non-linear devices? Like semiconductors and Zener diodes. And also it is not applicable to non-metallic conductors. Once again, you are thinking like what will be the non-metallic conductors? So that will be like silicon carbide, where the following relation, that is V equals to K into I to the power M, by considering K is nothing but and M is nothing but constant. Okay, so here these are the constant K and M. Only variable quantity is I and V. If current varies, voltage varies. So that it is not applicable to non-metallic conductors. It only applies to the metallic conductors. And also it cannot be applied to arc lamps. In case of arc lamps also what happens, the temperature the temperature is not constant in case of arc lamps. It's varying, so that you cannot apply this to the arc lamps. And the last point you need to understand, it does not hold good where the temperature rise is rapidly in metals. So you need to apply this Ohm's law to the temperature constant materials or else a constant parameters. If there is a variation of temperature, there you cannot apply Ohm's law. So these are the limitations of Ohm's law. So very simple and very easy to understand. So you need to understand the statement: at constant temperature, current flowing through the two ends of conductor is directly proportional to the voltage across the conductor by considering or else at constant temperature. So I hope you're understanding this concept. So let's come with a resistance in series, parallel, and resistance in series, parallel, differences, and also current divide rule, voltage divide rule in the next video. Thank you so much for watching this video. Keep support and please do a like, share as much as possible, and also don't forget to subscribe to this channel. Thank you so much. Have a nice day.